Hey, hello everyone. This is video number 3 for the lymphatic system. And in this video, I'm going to be talking about this part of the outline, and this involves a discussion of the lymphatic tissues and organs. So these are structures in the body that are going to be involved in forming or maturing or housing immune system cells, the leukocytes. This video is going to be focusing on defining some terminology having to do with these structures, how they're classified basically. And I have a short video prepared with some board work to discuss that. And then after that, we'll come back to the PowerPoint and we will talk about the primary lymphatic structures, which are the red bone marrow and the thymus. So let's take a look at this short video to start. Okay, we've been talking about one function of the lymphatic system, which is returning fluids back to the bloodstream. And that's through the set of vessels from the previous video. The other main function is producing, maturing, and housing cells of the immune system so that the body can mount an effective body defense. And so I've drawn on the board some of the main structures that are involved in this function. So these are what are called the lymphatic organs and tissues. And by the way, tissues is sometimes referred to as nodules, and I'll go into why that is in a second. So the lymphatic organs and tissues are structures that are either involved in producing, maturing, or housing immune system cells. And these immune system cells are the leukocytes mostly, the white blood cells, but there are others as well that come into play. So for now, we're going to keep that pretty vague, but when we get into the immune system chapter, we'll get into a little bit more detail about what those are. All right, so these can be broken down into the primary organs and tissues or the secondary organs and tissues. Primary organs and tissues are sites where these cells are made or where they mature. All of these cells, the leukocytes, are made in the bone marrow. So one of the primary organs is the bone marrow. Bone marrow, the hematopoietic stem cell, is making all of these different types of leukocytes, okay? Now, these cells, many of them have to undergo a process called maturation before they can be functional and they can work in body defense. And this is especially true of a type of cell called the lymphocytes, of which there are two main types, T lymphocytes and the B lymphocytes. So they are formed in the bone marrow. However, they have to undergo this maturation process to become fully functional. The B lymphocytes and a number of other leukocytes as well, they are formed in the bone marrow and they also mature in the bone marrow, okay? The T lymphocytes, on the other hand, are formed in the marrow, but they leave the marrow and travel to the thymus, and that's the site where they mature. So for that reason, the bone marrow and the thymus are the two main primary lymphatic organs, okay? And to keep in mind, the bone marrow is where all of these are being made, and most of them mature, including the B cells. B cells, bone marrow. The T cells are formed in the marrow, however, they mature in the thymus. T for thymus, okay? So those are the primary organs. So after these cells are formed and they mature, then they're disseminated throughout the body. They're going to go into the bloodstream and they're going to take up residence in places in the body where it's a good, think of it this way, a good place to evaluate what's coming into the body. Maybe susceptible points for pathogens to enter into the body. Okay? And these are the secondary lymphatic organs and tissues. These are sites where these mature immune system cells are going to be performing the function of immune surveillance, surveilling whatever's coming into the body. Is this a normal substance or is this some kind of pathogen? And if it's a pathogen, they will mount an immune defense against this, an attack, basically, to try to neutralize it or get rid of it from the body. So the secondary lymphatic organs and tissues you can break them down into the organs. The secondary organs are defined as structures that house mature immune system cells that have a complete capsule. So they're discrete structures and they are encapsulated. The capsule is just a fibrous connective tissue layer that forms the outer part of the structure. So the two main examples of the secondary lymphatic organs are the spleen and lymph nodes. They are encapsulated structures and they contain mature immune system cells taking on the role of immune surveillance. The secondary tissues or nodules are not encapsulated. They are still groups of a mature immune system cells. However, they're not in some discrete structure. They're embedded in some other tissue. And so they're still functional, they're still working, they're just not a structure unto themselves. Okay, the two main examples of secondary lymphatic tissues or nodules you'll find are the tonsils and the malt. Tonsils, packets of immune system cells that are in the wall of the upper pharynx, nasopharynx mostly, and the oral cavity. And the malt, mucosa-associated lymphatic tissues are basically that, right? They are packets of immune cells that are embedded in the mucosal membrane of most mucosal membranes, put it that way. But a really good place is what we talked about in the digestive system is the Peyer's patches. They're an example of mucosa-associated lymphatic tissues, groups of immune system cells that are embedded in the lamina propria of the mucosal layer of the small intestine and the large intestine. All right, so that's an overview of lymphatic organs and tissues, difference between primary and secondary, and within the secondary, difference between organs and tissues or nodules. All right? All right, so that's an overview of the definitions that we'll be using and classification of the different structures in the body. So let's take a look here on this slide, which shows those structures now. On the right side, primary lymphatic structures, the thymus. Here the thymus is located in the upper mediastinum and, sort of draped on the upper surface of the pericardium. And the red bone marrow, this is showing location in the spongy bone of the head of the femur. There are a number of other locations in the adult where you will find red bone marrow as well. Okay, primary lymphatic structures, place of formation and or maturation of leukocytes. On the right column here are the secondary structures. So these are locations for residence where these immune system cells, when they're mature, take up residence to perform immune surveillance and immune defense if necessary. So the tonsils, nasopharynx, and oral cavity wall of those structures. The lymph nodes are scattered throughout the body. You have a few hundred of those, but there are concentrations in certain places in the body. So in the neck, cervical region, in the inguinal region or the groin, another concentration, also in the axillary armpit region. So those are secondary structures. Also the spleen, upper left abdominal quadrant, and in the malt. So this could be any mucosal membrane, but a good example of that is in the wall of the small intestine, the Peyer's patches. Okay. All right, so for the rest of this video, just a little bit of information about the primary lymphatic organs, bone marrow, and the thymus. So the process of formation of the immune system cells, and in fact all formed elements in blood, occurs by the process of hematopoiesis, and that's by the division of the hematopoietic stem cell that is a resident of the red bone marrow. And this is just showing, this would be the head of the femur, just like from the previous slide. Red bone marrow occupying the spaces in the spongy bone. And it's able to make all of these formed elements, including the red blood cells and the platelets, but we're going to focus in on these. These are the leukocytes. Some of them are the granulocytes, neutrophil, eosinophil, and basophil. Some of them are the agranulocytes, monocytes, and lymphocytes. Okay. For the lymphocytes, the B cells, B lymphocyte, are both formed and mature in the red bone marrow. The T cells are formed in the marrow. They travel to the thymus to mature. And then for all of these, when they're mature, they go into the circulation, and that circulation allows them to eventually leave and take up residence in the secondary lymphatic organs. When I said all of these, I meant leukocytes. Okay, so a little bit more about the bone marrow and where you will find it, and this would be in an adult. So I mentioned the head of the humerus and the femur, also in the hip, the os coxa. You'll find it in many of the flat bones, the sternum and the ribs, in the vertebrae as well, and also the flat bones of the skull. So this is in the spongy bone spaces of all of those bones. Okay, hematopoiesis we talked about from the previous slide, and the T and B cells also. Okay, a little bit about the thymus next. So starting with some general anatomical features. So the thymus is located in the upper mediastinum, and it has two lobes, left and right. And those, the gland sort of wraps around the base of the trachea and drapes over the superior anterior surface of the pericardium. Now, the thymus, the main function of the thymus is to provide a site for maturation of T lymphocytes. And this activity is extremely important and very active, high volume process in young people. So infants and kids, prepubescent kids, this is going on at a very high level. After puberty, about that time, however, the process slows down. So the body is armed already with a lot of mature T cells, and it becomes less and less active as we age, as in the adult years. So the gland is very large compared to body size in the childhood years, and it regresses in size in adulthood. A little bit about the anatomical features of the thymus. So as I mentioned, there are two lobes, left and right lobes. And the thymus is encapsulated. So it's a primary lymphatic organ. It has a capsule. It's a connective tissue, fibrous connective tissue capsule. Now, extending from the capsule interiorly are fibrous extensions from the capsule, and these are basically barriers that extend inward, and they sector off the inner tissue of the thymus into chambers called lobules. So the extensions are called trabeculi. These are, basically partitions between neighboring lobules. The lobules are where the actual maturation of T cells occurs. So what happens is the bloodstream brings in immature T cells that originated in the bone marrow, and these are delivered to the outer surface of the lobules, called the cortex. cortex has immature T cells. And then these T cells are going to undergo the process of maturation. And as they do so, they move to the middle of the lobule, and that's called the medulla. So the immature T cells start out in the cortex, and they travel inward and mature and end up in the medulla. And there's a difference in coloration or pigmentation between these two regions, as you'll see on the next slide. Eventually, what's going to happen after the T cells mature is they're going to exit from the thymus in the bloodstream, and they're going to take up residence in the secondary lymphatic organs and tissues. All right, so this slide is showing child gross anatomy versus adult, and one thing you should notice is, number one, position of the thymus. So let's look at the child first here. So, and I mentioned upper mediastinum and sort of wrapped around the trachea. Here's the trachea, would be running through the center here, and draped over the superior and somewhat anterior surface of the pericardium, which would be surrounding the heart. Okay. And the other thing you should notice is the drastic difference in size between the thymus in the childhood years versus the adulthood years. So much reduced in size in the adult. And you may have seen this when you did dissections of cats and minks earlier in the semester. Same thing holds for those animals, general feature of mammals. So if you had a relatively young animal, the thymus would be very large and definitely draped over the superior part of the heart. In older animals, there would be a space between the two structures. All right, this also shows a histological section through the thymus of a childhood thymus versus an adult thymus. And you can see not only is there a difference in size of the glands, but the actual functional tissue, the lobules, is pretty much filling the gland in the childhood section here. Whereas in the adult gland, there are just a kind of scattered pockets of active lobules, and the rest of the gland is made up of connective tissue, fatty connective tissue, adipose tissue. So not only is the gland smaller, but the number of active lobules is greatly reduced as well. If we look at the childhood histological section here, we can see some of the other features I mentioned from the previous slide. So each lobe will have a capsule. That would be this structure here, fibrous capsule, relatively thick. And extending from the capsule are the trabeculi, the partitions that extend inward. You can see some of them here. Some of them, not all of them, are in the plane of the section, but they would sector off a lobule. Here's a lobule. And the outer part is the cortex. That's where the immature T cells would arrive in the bloodstream. And they're going to travel slowly inward to the medulla. So here are the medulla. You can see the difference in pigmentation. And then rich in the medulla are the mature T cells. And when they finish the process of maturation, they're going to exit via the bloodstream to take up residence in the secondary lymphatic tissues. All right, so I'm going to end this video here, and the next video we'll discuss some of the secondary lymphatic structures. See ya.